Welcome everyone to the Event-Driven Microservices Conference 2020, a virtual conference because of our current situation. It's a big pleasure for me to present the keynote about event-driven systems. It's something that's changed the way I work over the last more than a decade now. I come from a long tradition of software development from the 80s all the way through to today. So my name is Adam Dymitruk, and I've been working in event-driven systems, like I said, for quite a while. And there's been an incredible amount of insights gained by thinking about events and how we understand our information systems around us. We kind of concede now that human beings have kind of thought of information systems as records of account for a majority of what we did throughout our history. This gave us quite an interesting insight. So through this conference, we'll have many people give examples of the advantages of writing systems this way, constructing systems this way, and having basically a much more human way to think about larger, more complex solutions that you have to automate. And I'm trying not to use the word software here because we really are talking about the entire system, the usability, everything that's involved. We'll see how by getting the technical sides to be in sync with how we work in putting together information systems in any kind of way, that it's a big advantage and removes this mismatch that we have. Sometimes we're looked at as geeks that don't understand the business, and I think that's an indication of a bigger problem within organizations, how we communicate and organize. And so this is one really big advantage that I saw with event-driven systems from the very beginning. And once I switched to writing systems with event sourcing specifically for myself, we'll get into all the different topics such as CQRS, domain-driven design, event sourcing, event storming, event modeling, everything to do with events we'll have at our conference. So hopefully after this presentation, you'll stick around for all the other people that are presenting and see their trials and tribulations as they introduce this better way of thinking. Personally, I switched my entire business to only work off of event-sourced solutions to have a record of account for everything that's done in the system. It's been a tremendous advantage technically, but also from the business perspective. Many clients that we have like the fact that they have a trail of breadcrumbs as to how they got into a specific predicament when inevitably problems arise in our systems from whatever source. The other interesting thing about event-driven systems is that no business is static. So if we look at the traditional way of thinking about systems, if you go back to UML or anything else like this, and object-oriented programming and traditional three-layer architectures, we try to do a job of capturing and encapsulating that business in a set of objects or something that represent how we understand it now. Well, that even if we're correct, that abstraction is almost immediately stale. So event-driven is a way to really give account as to what's going on at any particular time and not be tied to what we thought the best abstraction was somewhere. So it's a very natural way to progress alongside with business and keep a proper account of what happened along the way. It's also a really good way to integrate separate systems, to rely on publish, subscribe, as you will definitely have some presentations about Kafka and other technologies to be able to broadcast what one system is doing so that other systems can react and really have what we generally have in the real world as human beings when we subscribe to a newspaper. We have a source of information, and then there's the consumers of that information. So we have natural patterns by doing event-driven. And so this has greatly affected, as I said, how things are how things are done in my organization, to the point that we had to develop our own way of doing specifications, because that old static view of what an abstraction is and what we want to do is much different when you're doing things in an event-sourced way. So we had to come up with a better way to show or collaborate on requirements. And of course, there's a lot of prior work to get people into a workshop to collaborate together. And that was a lot of work done by Alberto Brandolini with Event Storming, where he had a lot of people go in and basically collaborate from a number of different disciplines. If you're a product owner, if you're a developer, tester, all the way up to CEO if the organization is in the right structure to allow for that. So, and depending, maybe for obviously a startup, that's something that you would naturally do. So getting that collaboration, having people together to really not do things behind closed doors or in silos was really eye-opening. The story aspect of it came from Greg Young, who did a lot of work in CQRS and event sourcing, and being able to talk about long-running workflows as a set of events over a timeline. Well, putting Alberto's and Greg's ideas together gave rise to event modeling, which really is about, the thing that we can relate about systems is that if we talk about stories, we'll have something that everyone can relate to. And so event modeling is my contribution to how we think about event-driven systems. So I'd like to take you through a set of slides quickly, and then go through some of the tools and techniques and other resources that you can use to help you yourself and your organization do similar things, and have another tool in your tool belt, if you will, to tackle some of the problems with either in your own organization or if you're consulting to help your clients out faster in a more human way. So let's see if I can get the Zoom sharing correct. I had a little trial run before. Let's test out how I can present. Okay, sharing the presentation now. All right, so I call this event modeling with one L simply because that's the less common spelling. So if you Google for this, you'll be able to find everything that's written about the subject. As I said, that's my introduction. If you have any questions about this particular presentation or any topics that I touched on here, feel free to reach out to me on Twitter. There'll be also other places like Slack channels that I'll note and show. So as I said, the human mind is a very interesting advantage that humans have over the other animals, and it really makes us different because what we can do, and I think there's some research showing that some animals can do this, but what we do is we can save our memories and instill them in the next generation. So civilization is built on this. We simply don't have to reinvent the wheel every time we have a new generation. So information in society is key. If we understand how that developed in the human mind through evolution and how we had this advantage, we'll understand how to build systems that are in a way that's more advantageous for us because we'll be using the same mechanisms as we had. So one of those interesting things is that this is a ledger for trading back in the 1800s, but the human mind, if we go back to this, how did that first occurrence happen when we passed on some information to the next generation? Well, it's usually some stories. Usually it's a tale of what happened to a previous generation or some, great warrior or any, if you can imagine cavemen sitting around a fire and drawing in the sand with a stick to tell a story, painting on a cave a series of pictures depicting how to hunt, or verbally talking about a fairy tale to a child, all the way through to the Bible. So this happened well before the written word. And it's our mind's ability to take a few cues, take a few keyframes, and be able to retell an entire story. So even a 5-year-old child can remember a story of Hansel and Gretel or any of the other fairy tales. And you probably didn't need to study that fairy tale until you had your own kids, and somehow you were very quickly able to pick up what the story was and make up the in-between pieces, but the same story continues through generations. So the idea that the human mind can store a lot of things is taken from these cues of key frames. And we'll see how event modeling takes advantage of that these key frames are very, very strong. They're very small pieces of information, but they're incredibly powerful. And if we just trust the human mind to fill in the blanks, we really reduce the complexity of how we talk about systems. So this will all make sense together at the end of the presentation. But it's really important to see and be honest to how humans can relay information to one another in large organizations or from different roles. So we see a lot of this evidence once we get formal systems such as organizations and companies. And this is a trading ledger from the Hudson Bay Company in North America, I believe. And it has some sort of record of account of what the prices were for beaver pelts and things like this. You can also see that ink was one of the first ways to paint. So we had a very permanent way of talking about information, and we just ended up adding more information rather than having a pencil and with an eraser. Now, there are some clay tablets where the clay on purpose was not hardened, and you could erase it just by pressing down on it and reuse it again. But those are the exceptions. For the most part, information was put into some sort of a ledger. We always used ink, so it was an additive only process. And we'll see how that relates to, for example, event sourcing by not storing a particular state and changing those entries, but rather adding more entries and then allowing the analysis of what was entered to make up your mind as to what state our system is in or a part of our system is in. So hopefully that makes sense for you to see that we have already had a lot of this way before we digitized anything. One of the key insights that we gained in the early days of computing was in the Mythical Man Month by Fred Brooks, where he liked, he could appreciate all of the fancy flowcharts and algorithms that we do, but ultimately what would tell him what the system does is by looking at the state and seeing what's on disk, seeing what's in the tables. In our case, it's seeing what events have been stored. Those are the things that will ultimately determine what the system does. So information systems fundamentally are about information. And Fred Brooks had this nice insight into it back in the 60s. So none of this stuff that we're talking about is really that new. These are really, really old concepts. And what we found is that just the computing power around us has made computers way more ubiquitous, and that level of being close to them, we're not at an arm's length anymore. We don't need as many interpretations to do something with computers. So it's kind of time to go back to the way we were, because we don't have to make special amends for computers. We'll see how traditional architectures kind of did that, were forced to do that. There's another presentation that I do where I talk about the storage problem and Moore's Law, but looked at from the perspective of storage, that we really couldn't, at the beginning of computing, store everything, have a ledger, because hard drives were expensive. In the 1950s, an IBM hard drive was $1 million, and that's not inflation adjusted. It weighed a ton, and stored 10 megabytes. So if you wanted to store the old address for your client as well as the new one, well, you have to have a very strong business case, because you don't want to have to buy 2 of those hard drives. You only wanted to buy 1. So everything that we see about how we organize information in computers is kind of, it's based on those early years of needing to make some sacrifices with what we had to do with information. Now, there are backups and things like this, obviously, but the key point is that it wasn't online information. So absolutely, I could go manually find some printout or some backup and see what the old address was for my client. But you certainly have to have a strong business case to make it online so that I could just see that old address at the press of a button. So I encourage people to look at what Fred Brooks has talked about back in those days, and see that state is really a powerful way to think about systems, and that code is really just a means to an end. And that's quite important to how we evolved from what was good for static systems that needed to look at a specific point in time to something that's more dynamic and has evolved over time, which is event modeling. So as Fred Brooks said, show me your state. Well, let's even do better. Let's show how we got to each state. So we do the specification by example to get the storyline. This is a system that is my canonical example of a hotel, an automated hotel where people can check in, book rooms, rooms get cleaned, people come and go, and the reservations are made, and we have a sales report. But the interesting thing is that this blueprint is done over time. And this goes back to my initial slide about how humans are better able to think about stories and be able to recall things. So when we walk through, if you're teaching someone a new concept, it's always nice to be the example, set the example, show them how you do it, and then they can see what things you do in what sequence, and they can copy it. And that's essentially what we're doing here. So whether it's telling stories, whether it's showing techniques, whether it's seeing a series of images of progression, our minds are built to consume this linear progression. And so when we present a system, instead of a bunch of static boxes with many arrows going different ways, if we have this sequence over time, sort of like your version history for source code, it only moves forward for the most part, and you can see how you got to certain places and why, and there's code comments on there, and it shows commit comments, I should say. It tells you why things changed, right? We're not just looking at this as a bunch of entries that we use a pencil eraser to take out the old entry and put another one in. We're talking about, people leaving the hotel room, people registering. There's business language. This is what our business is doing, or our organization is doing. And we're capturing that. There are some projections that are your typical tabular ones, or you can have graph databases or anything else you like, which are our green boxes that are projections of the state. Our room availability, we certainly don't want to read a whole bunch of statements of account of what happened with people leaving and coming and going to the hotel. We just need to know what is that room availability. But it's important to see where that information came from. So it's quite important. So specification by example is traditionally known as act, arrange, assert, given, when, then, and a few other flavors depending on where you're coming from. Even the UI, UX people have an intention, situation, motivation, value, I believe is what they have. So in each discipline, we have this, going back to this by example. And so if we actually have a blueprint that satisfies the UX and the UI and the actual logic, people will be able to know what's going on. Now, for complex systems with a lot of background tasks and automation where there's really no view, we actually want to have these little gears that I'm showing here, that these are processors that we show on the timeline. And in the real world, maybe there's a little spinning circle as you're waiting for the system to do something for you. But if you're talking about what the system's doing, you need to show what transformation the information is being subjected to. How is it logically being manipulated to have the outcome that you need? And this has to be something that everyone can understand. So as you can see, we've really put in the emphasis on the UX UI. So that, because a lot of people are visual, there's a certain large percentage of visual thinkers that human beings, certain percentage of the population is. And there's a lot of analytical people. Absolutely, lots of them are programmers, obviously. But we need to satisfy both sides, because that's what comprises most of our organizations. People that are visual and people that are analytical. So in an event model, we marry the two so that people can follow along. If they're more visual, they can see the example data at the top. I've left out the example data in here just for simplicity. It would be just too many things that would be writing. I did add it for some longitude and latitude. The other thing that we've done is that we don't want to have a really large amount of patterns to follow, etc. We want to find out what the core small little patterns we have, so that we don't have to study a book of 100 patterns to be able to use something like this, because then it becomes a niche thing. We now have a silo of information, and we have a really tough challenge to teach everyone what to do. So here's some more of the details. You might say, well, yes, our invoice might look, might have 12 different ways that it can calculate something. Yeah, those interesting parts of our domain we can explore with given when then. And this shows those given when thens below an event model. We'll go to some more example event models, but we can show how certain views evolve with more and more events, and we can graphically represent that. Of course, this seems very formulaic, and that's good. That means we can automate quite a bit of this, which we'll get into later on. But this is essentially a way to still use that story-like attribute of our brains to talk about a detail. And what we're doing here is basically the yellow stickies are events, and we can show more and more of them happening. You just build up on the previous one. And then below, you can show what specific views or reports or screens, what they're showing, and what change would happen with each additional event that we would do. So it's very easy to deconstruct a complex problem by slicing up this set of changes to state and explain at each point why a certain change has happened. So there's been a lot of examples of really complex domains where a 45-minute discussion in front of a whiteboard, doing things by example, has made it clear. Some of the largest companies in the world have used this to deconstruct quite simply and effectively a complex problem, but more importantly, in a way that's consumable by many different roles in many different departments, so that we really allow freer communication and more collaboration. So that's why we have fewer patterns. And as you can see, we only have 4: state change, state view. At the bottom, you can see that there's a state change, a state view, external state input, and external state output. Really, the last two are just a variation of the first two, but we're talking about system-to-system communication, either receiving or sending information. If we follow these, we can get a very nice velocity, because we're continually using the same 4 patterns. So the occurrence of these patterns will be very plentiful. Whereas if we start to talk about the details of implementation, we talk about observer pattern and whatever else you have out there, even enterprise integration patterns, we really start to put a huge amount of information that we need to learn before we're able to communicate. So the goal with event modeling is to take the opposite approach. Give us some simple patterns, very few of them, and elaborate more complex things on the timeline and spread that complexity out horizontally so that we can analyze it. And that gives us some interesting advantages, which we'll get into. So this is one of the most complex ones, a trading system, automated trading desk system that was deconstructed. The core part of it was done in 2 days. Follow-up event modeling sessions happened, but it's a blueprint that this company now uses to continue to evolve the system. And it really is like a blueprint for your house. You know where the plumbing is, you know where the electrical is, and if you need something done on your house, you always pull out this blueprint so that you know where you can, what you can do, which walls you can drill into, or where you can make an addition to the house. So that's essentially what we're doing for information systems. So it's making information system automation more like an engineering practice, where usually we've been kind of thrown things over the wall to the technical people, and we'll just use Agile to see how they're doing. Here we can be more responsible together for the whole system. So it's a more collaborative approach, a more dedicated one. It's kind of like small design upfront instead of big design upfront. So we can do everything that UML was trying to do, but without all the complexity and the details. Notice that we also don't look at, which algorithms we're going to use and how the code's going to behave. We're strictly looking at what is the state of the system. We don't care what happens when we press that button. We know that we have an intention to register, and that we only store the fact that we're registered. Whether this is running in Scala or Kotlin or whatever language is really immaterial. What matters is that if we shut the power off after that happened, that's the truth that's stored in the system. And it's really important to have that separation of the means and the end. If we concentrate on what the goals are along each step of the system through time, then we can allow people to be a lot more free to basically implement whatever way they want, as long as the SLAs are met and the data is correct. So it gives a tremendous amount of freedom. And again, we would want to have, if we could put all of domain-driven design, the contents of all the great books on domain-driven design in people's heads, we would do it in a second. But we know that that's a lot to learn. So what we need to do is find something that does has the same effect, but does it in a much faster way. Because if I was going to give a couple of thick books about domain-driven design to everyone in my company, it's probably going to get a month. It's going to take a month for everyone to read it and try to understand it. And we're going to have hit and miss understanding, and obviously some people may be too busy. So after that month of initial reading, it's going to probably take a year before we get 90+% of our organization to be on board and understand how to use it. I certainly have gone through many years at different organizations trying to instill domain-driven design across many different roles within the organization, and it wasn't easy. And so I asked myself, how can I do this without that tremendous burden of having to learn so much? And so event modeling is something that you can explain about 15 minutes. You can say it's a storyboard. We're making a movie about the system we would like, and we're going to walk you through what that looks like. It's as simple as that. And so we need to now concentrate on actually practicing. So you want the explanation to be very short and the concepts to be easy to understand. So we should be able to get pretty familiar with what that is within 15 minutes, but then use the rest of the day to really become familiar with it through practice. So those two timelines are very important to consider. If you're wanting something in your organization, this is very important when you're moving a new organization to event-driven systems. You're going to have to worry about how long something is going to take to teach. And there's going to be people that are not interested. There's going to be people that actively don't want to change. And then there's people that actually want to change. And you have to really think about what you're using to do that. So I'm hoping that event modeling gives you a very fast way to gain the goals that you're looking at through user story mapping, through domain-driven design, through all sorts of other disciplines and practices that you like, but that you have another method of doing the same thing. And it could be as simple as having a napkin over lunch that you're drawing with a pen, and you can draw a few screens and write down a few events over a timeline. So if that's usable almost immediately to actually implement some of the system, that's great. Then the business person you had lunch with can see that particular piece of the workflow is automated. So what do we get from planning? We had this big design upfront problem back in the day, and it was quite onerous, and it actually came from the legal side of the business, where the people that are specifying the system couldn't be the same people that implemented the system. So you had a fight for the budget. And so this is where waterfall has a really bad name, but it's really an abused waterfall history that we have. So it's always a scapegoat for Agile. But small design up front really does give you a constant cost curve, especially with event sourcing and other event-driven ways of dissecting a workflow. So what we found is that if we work with an event model, if we talk about what events are going to be stored in the system, when they're going to play with different, come into contact with different screens, etc., we notice that we're removing rework. So in the traditional way of developing, we would have maybe a registration screen where if we're now doing email recovery, password recovery, or a verification code, we'd have to go back to that initial registration piece and change that table to now maybe store that verification code, a number of retries and things like this. So as we add more features, we add rework, and these stack up. So this is usually why we end up with a death march to projects where we have this, things are really on the Greenfield project. The first 2 weeks, first 2 months are wonderful. We're getting features out, 3, 4, 5 features a week, even more. But once 6 months or a year or 2 years rolls by, it's like moving through mud. You can't get a feature in there. And that's because we have this coupling. And this is another thing that event-driven systems do a good job at, if done properly, is that they have a good handle on where the coupling is and how you avoid all the bad coupling, which gives you that really bad red up curve here in cost. So the more pieces that are interacting, the more relationships you have to analyze, and so that's where the complexity goes. However, if you concentrate on state and have a place for each piece and where it's going to go, you reduce that rework significantly to the point where you can follow open-close principle almost to the letter. And you can also see it from a business perspective. So that open-close principle is not a technical concept. It's an information system concept. And this is where business will appreciate what you're doing, that you are talking about not having to add extra expenses to rework things because you have the ability to say, I'm done with this feature, and really, unless my requirements change, I don't have to crack open that code. I can see that piece of the workflow already working. For traditional systems, and this is quite important for us, if we're doing event-driven architectures, and we love doing all the pub sub and all the things that that really works for us. We have ubiquitous language. We have different models that we employ for different purposes. So we don't have a canonical model that gets rid of some of the bad coupling. The reality is that most of the world is still traditional. So the last thing that I'm adding with event modeling is talking about event modeling for non-event driven systems. And you'll get so much further ahead if you have a bridge between traditional and event-driven systems. Sometimes we're in a bit of an echo chamber talking to another. I know we're trying to perfect our craft. That's great. But at the same time, we need to be building bridges so that we bring onto our side all the people that want to build systems in a better way. So event modeling works the same way for traditional systems. The only thing we're doing is the views of state and the commands, which are green and blue, are your SQL statements. It's interesting to show how the coupling, happens, and that if we were to do the user registration, that code part wouldn't be in that table. So this is that example of cracking open something that we already were finished with, and that's a simple example, but these can get much more complex. So the idea is, these events don't get stored in a traditional system, right? They get thrown out. But this is the truth. This is what was in the user's mind when they did that action to register. In their mind, they know what their password is. The system is actually storing the hash. So we start to see where we have the mismatches in terms of what state we store how our system acts with what the person was trying to do with the system. And that's quite important. So in a traditional system that's not event-driven, these orange stickies in this case get thrown out. You don't have that in your implementation. But sooner or later, some people will start to ask, why are we throwing away the information in those orange stickies? I get it. We have our Ruby on Rails and we're going fast and we have these tables in our ORM, but I'm looking at this event model and saying, is there an advantage to keeping this around? Because I'd like to see, what the old verification code was or what the old email was for that user. Right now, I'm trying to even, get old versions of the source code to see how that happened. But with events with event sourcing, this is particularly for event source system. You can talk about the advantages of keeping your events and how that's an advantage. Of course, there are challenges from moving someone to this way of thinking and this way of doing things. As you get more and more events, people say that it takes a long time to replay them and find things. So you still have problems of organizing your information. They're just different. They're not harder, but they're different. Here you can show exactly those differences and what the system would have to do if we were to keep those around. So hopefully this gives you a way to transition people from traditional architectures to event-driven architectures where you can do your microservices and all the decoupling that you want and be a polyglot developer. But yeah, one of the things that I bring up is that with an event source system that's done this way and actually planned this way, is that you can start to really mix and match all the different types of technical stacks together, even in the same workflow for the same application, simply because that amount, the rework is removed. So if there's any real changes in the requirements, you're replacing entire workflow steps. So there's no need to have a Ruby person change your Java code or vice versa. You simply replace those state transitions. And new things like serverless are really good at doing these types of things. So, looking at this from a functional perspective, a lot of people like functional programming and a functional perspective on this. If we look at all the events that have happened over time, we can start to whittle them down. This is when we start talking about Kafka topics versus event store, fine-grained streams, and how we can start. I usually start with event-driven systems or event source systems with just storing the event and not even having any projections. At the first, when you're in the proof of concept stage, you don't even need to have materialized views of some of the models. You can just keep reiterating over those sources of truth that are the events. Now, obviously, past the demo stage, it's not going to be very performant. So you start to materialize those and actively listen to them and keep them updated, whether it's in memory or on disk, doesn't matter. But you start to make, adjustments for performance. The interesting thing about that, though, is that the integrity of the system stays the same. Your actual event handlers and command handlers don't change, which is beautiful. That's when you can really show that you can throw different infrastructures on your problems, but it doesn't affect your functionality. That's a big advantage. Some things like aggregates in domain-driven design, when we look at it from a functional perspective, we can see that really we have a whole bunch of things we assume about state that we don't need to. So for example, if I was to close an order, I really don't need to know what address it's at, etc. So we start to dissect some of those things that we learned in domain-driven design to be a little bit, not quite as simple or performant as they could be. So moving through functional perspectives, this is just one way that event-driven changes even domain-driven design thinking, where you can split an aggregate apart into a more functional paradigm and start to look at the events themselves instead of always artificially grouping them together just because they share the same entity ID of whatever the aggregate root is. So hopefully that gives you more ways to slice that up. So when we look at some of our specific pieces of our event model, we can also mark it up with certain things. So the given when thens are interesting. We have cross-entity invariants and things like that. We could really spell out why certain things cost twice as much to build to our business. If you have a cross-entity invariant, you'll have to show that you need to first get a view of what the other entities have, and then put that through into your command, and then do that. So in terms of those workflow steps, that may be 2 of these instead of 1, and so that's why some of our requirements may be twice as expensive. These are just some examples. The polyglot approach, we do this in our meetup to explore, but we certainly can have multiple ways of implementing a system, and the user will be none the wiser that that website that they're using, even workflow steps that are very close to one another, are implemented in entirely different stacks. They sit on entirely different Docker containers with entirely different people working on them. That's quite important from an organizational perspective. This ability to dissect a workflow into slices gives you the ability to hire someone that doesn't have the same technical experience, but they have domain experience. So if you're in the inventory management kind of domain, and you have someone that's worked at automating the Amazon warehouse, but they're highly skilled in Ruby, but you're a Java shop, are you going to send them on their way, or are you going to allow them to come in and contribute to your solution? So of course we want to hire that person, and we don't want to force them to learn a language they're not efficient in, unless they of course want to. That's fine. But we start to see that the polyglot approach is not as expensive as it is with traditional approaches, where you can't have this segregated way of doing these workflows. Now, you can to an extent, but it's a lot easier when you're dealing with an event-driven system, event source system, where you've really lined up state transitions as these slices, and you have command handlers and event handlers that are quite isolated for being automated on their own. They really don't rely much on anything else besides state. So there's many advantages of that, and this is just scratching the surface of this. There's some things you want to share besides the state, such as templates for some HTML and other things, but you certainly can come up with a scheme where you allow this to go across multiple programming disciplines at least. So looking at this, how does this blueprint help everyone else? Well, the top swim lanes really help the UI UX designer, but they're held accountable to what information they put into their mockups, right? They can't just dream up crazy situations that are going to cause the developers headaches, and they'll come back after 2 weeks going, this is impossible, we don't have the right information. So having the ability to work with UX UI people collaboratively about what information is there is incredibly important. The architects, they look at the swim lanes. We have inventory, authentication, payments, and GPS in this particular one. So architects can look at timelines for SLAs, input-output, what is actually getting stored. They can start to analyze storage requirements, all sorts of things. Developers can develop every vertical slice at a time. So this is very important, because from the PM and the developer side, these give you a really good velocity to the point where we only do fixed cost contracts, because once we have an event model, we have a really good grasp on what the project's going to cost. And we put our name on the line saying that this will be done for this amount, because, hey, if we rush it, we have to fix these things for free. Like, if it's not done up to spec, you have to fix it for free. Of course, there are changes with requirements. That's a different story. But at least you have a quantitative way of saying what the changes will cost. So if the client or the organization wants to change the requirements, they have a very natural change management process here, where they basically hold up one blueprint versus the next, and they can see which parts are already done, which will require rework, because you're going to have to remove those pieces that no longer apply, But the ones that aren't implemented yet, well, that's a free change. And you specifically see how that state is done. So QA obviously has a very easy way to elaborate stories. They can mix and match to see if there's a bad actor in the system as well. So even from a security perspective, if you have a security auditor, if they understand how your system is used, they're not just blankly staring at APIs. Who knows when they're called and how and why. Now they can refer to this and see that this is the way the system is used. And now from a security perspective, I can do some different threat analysis to see if people can take advantage of a blind spot in some sort of different order that I can, call these APIs in and create a situation where I can do something against this company. So it's quite useful. So hopefully this gives you some thought. And as you listen to all the presentations today and over the conference, you'll think about how you can present all those technical concepts to your clients, to the non-technical people, to your UX, UI people, whoever else, whatever other teams you have. I'm hoping that through event modeling, you'll be able to have something that you can rely on throughout your project, not just at the beginning to collaborate once at the beginning, but you continue to use it to reference as a map later to find things. It acts as a blueprint and then as a map to find things. So I'm hoping that you get some use out of it. There's a book coming out on this, and there's all these different ways to get involved in this event modeling. I can show some of these right now as well. Let me just stop my sharing for a second here, and I can show some of these. All right, so first, resources. Where can you read in depth about this? So I'm going to share my screen one more time. And here we are. So the first place where you can find a lot of this information is in the eventmodeling.org website, in the main article, which was the main blog post. What is event modeling? What is it? And it has all the sections that we talked about, but in a lot more thorough explanation. So we go through a very detailed way of explaining each piece that we talked about. We really didn't have time to dive into all of this, but I'm hoping that as you look at how to hold an event modeling workshop, how you evolve and build one with people in a nice structured way, how you can do the project management by counting which slices have been done, analyze that cost curve, because this is going to save your bacon quite a lot of times on projects. It's quite a good one to understand. And many other things, including legacy systems. So how do you go from a monolith to some sort of really badly coupled monolith? The monolith itself is not a bad word, but where there's a single canonical model inside, etc., and code you don't understand, and it's walking on eggshells to change something. Those are, how do you apply event modeling to show how you're going to sidecar a new event-sourced solution and not have to swim in that code and start to analyze it scientifically and do that. So I have a nice example here of fixing a bug and adding a feature to an existing system. So that's the main article. That is they're going to give you the most information about this. We've been using Miro for a time tracking application during our meetup. So you can join us in our meetups if you like to play around with our time tracking application. And over the last year or so, a lot of different companies have been looking at automating this to generate code, but also to have some of those opinions. So ONote is the latest and greatest in that way, where you simply can drag new events up and call them whatever you like. I'll just say example because I can't think of one right now. But more importantly, if you need to show a particular command that will jump up, notice that there's Notice that we can only drop them in certain places, so it has some guidance as to how to do this. So you have a tool that will guide you to do it correctly. And so also the connections are as they're supposed to be. We have this cadence. Commands can only end up as events. Events can only be looked at by read models. This is quite important to ensure that we follow those 4 patterns that we showed before. Read model or view. I like to call them views because I don't want to explain to someone what a read model is, but some people just know that the view of state is something that's a report maybe. So I try to use common language so not to confuse others or have to make them study some more things before we can communicate. So as you notice, we can't connect a command straight to a read model. The nice thing is that this saves to JSON, so you can transform this to any code that you have. So if you have boilerplate code and you have a certain way to do command handlers and event handlers already, you can do that. So this is pretty exciting. There's lots more. There's other companies that are making code automation from an event model, because the nice thing about an event model is that it gives you information completeness. In other words, all the example code that I have in here has to make sense. I can't have some data appear out of nowhere. So this audit of information completeness is incredibly powerful in event modeling, because before you start a project, if you have some assumptions, well, it would be nice to have those answered so that your project doesn't blow up with some detail that was omitted. Now, maybe it's on purpose, maybe it's by accident, but that information completeness of knowing where things come from and where they're going and why things are displayed, that gives you an ability to have a very good estimate, which has been really hard to do in software. So for the first time, we have estimates that are reliable because we have a good way of tracking velocity through a small set of patterns, and also being able to show that we're information complete, as we like to call it, knowing where all the information is coming from and where it's going to. A real good way of doing systems thinking, that rectangle that you control and everything inside it, understanding where there's inputs and outputs and be accountable for all of them. So that's a really good tool to use, and I hope you will check it out. And then our meetup happens twice a week, generally, unless I'm sick or just too much work, but generally Tuesdays and Fridays. I'm on the Pacific West Coast of North America, so I do that in the morning. So even if you're in Europe, you can stay up and join us online. Everything's virtual these days, as is the conference. So it says Vancouver, BC, but it is a virtual one that's all over the world now. So I hope you join us. That's where we do the event modeling for time tracking and do some CQRS and event sourcing implementations, talk about domain-driven design concepts, microservices. We argue about event sourcing and what that is and what it isn't, why Kafka's good in this case and why you want to use something else for another case. So really exciting topics that we like to talk and discuss about. And we try to put those on YouTube as well. So as far as resources, the eventmodeling.org/resources, the resources page will have the Slack groups, some of the intro videos that you have, some example code, some laptop stickers. I have some new ones actually that I should show, but that's pretty much it. So the new event modeling stickers are kind of exciting because they're done in Breaking Bad style. So if you remember that show, we have the secret sauce to making good information systems. That's why we borrowed that concept of the chemistry from the Breaking Bad series. For those in Europe, you should check it out if you haven't seen it yet. But I hope that you have had some interesting insights into information systems and how you can talk about them more freely and more widely with others in your organization, and how you bring some of the technical concepts up and into general concepts that the whole organization can share responsibility for. So that, I think, is my best contribution to this entire event-driven world, and it's a fairly new concept. The book is on its way, and there's many other workshops and other things that we'll be doing. It's the only way we do requirements with our clients for any project. We simply don't want to start a project if we don't have a good idea of how it's going to treat information. And if we don't have a good example of what success looks like. That event model is the story of your complete system running over a year or something like that. And you can hold it up to the light against the actual solution you produced and see if you succeeded. And that's a great advantage. Everyone knows what's going on. The costs are fixed. It's very transparent. We always invite our clients to talk directly to our developers because they have a way to communicate without needing translation. So we don't hide behind technical concepts. We can talk about state in a way that's generally understood by everyone. So welcome to the conference, and I hope that this gives you a little bit of an extra tool in your tool belt. But the remaining talks are going to be quite interesting because you're going to hear from a lot of people and their strategies of how they were able to succeed using event-driven microservices in organizations that were doing it for the first time. You're going to learn about all the troubles that can come up and how you can get around those through their experience. So I hope you stick around and look at the entire conference for all that it has to offer. And I'll be in the Q&A chat, so I hope to see you there. And I'll answer anything else. But from here, welcome to the conference. Enjoy yourself and interact with all the speakers. They'll be around during the presentations. So thank you so much for having me.